right, so your picture here is a picture of a general parallelogram. We have side AB is parallel to CD or DC, however you want to name it. AD is parallel to BC. So you have two pairs of parallel sides. That's obviously one conclusion. That's pretty obvious. That's the definition of a parallelogram. But let's also talk about the fact that the first property you need to write down is that opposite sides are not only parallel, they are congruent. Opposite sides, so when they're across from each other, are congruent. So that means AB is congruent. The congruent symbol is an equal sign with a squiggly line over it, is congruent to DC, and AD is also congruent to BC. So not only are those two sides parallel, they are also congruent to one another. We've already got some congruent symbols on our picture. They're on our diagonals. So let's mark the sides as well. We've already used one hash mark and the double hash mark. So when we mark AB congruent to DC, let's use 3 to indicate those two sides are congruent to each other. If we just use 1 or 2, we would be saying that those sides have the same measurement as this part of this diagonal or this part of that diagonal. So we have to use a different number of hash marks. And then the left side is congruent to the right side. So let's use 4 hash marks to indicate that congruency. Okay. I want to make sure that you can recognize all the symbols, because they may just give you a picture, or they may give it to you in words. I don't know how they're going to present it to you, so I got to make sure you know all the different representations. So that is one property. Another property, looking at the picture, let's look at those diagonals. Look at how they are marked. This part of the diagonal and that part of the diagonal, they both have 1 hash mark. So that means those two pieces of the diagonal are congruent to one another. The same is true about the other diagonal. The two pieces of the diagonal there, when you are talking about splitting it up right there in the middle, are equal. So that means that the diagonals bisect one another. Okay, that's another property. Diagonals bisect each other. So E is that point in the middle. So that means that AE is congruent to EC, and DE is congruent to EB. Diagonals bisect each other. Now, this third one, a little bit of a no-brainer, because this is true about all quadrilaterals. All angles add up to how much? 360. Again, that's true about all quadrilaterals. Rectangles, squares, rhombus, trapezoids, anything that's considered a quadrilateral, all angles add up to 360 degrees. But I wanted to establish that just in case we had forgotten or someone did not know. Okay, speaking of angles, another property about our angles is that opposite angles, so like opposite sides, they are across from each other. Opposite angles are, looking at the picture, what do you think the conclusion is about the opposite angles? They're congruent, okay? They are the same. So this picture is drawn to scale, but if you ever came across one that was not drawn to scale, it is important to know that property. So angle A is congruent to angle C, and angle B is congruent to angle D. We could mark that on our picture. We can mark it A congruent to C, B congruent to D. Now, I know in this picture, particularly with D and B, it looks like that diagonal may be an angle bisector, that it cuts angle B and angle D in half. That is not always the case. Okay, the diagonals in a parallelogram do not have to be angle bisectors. They could be, but they do not have to be. In a square, they would be, but you can't say that about all parallelograms. Okay. Last one here. What if I said adjacent, or you may also see the term consecutive angles are, what do you think the conclusion there might be? Are they congruent? No? Okay. First of all, let's make sure we know what adjacent or consecutive means. Okay, that means they are beside each other. If you are adjacent to something, I am adjacent to Miss Joyner's room. Okay, our rooms are right beside each other. Or consecutive, they come in order. Okay, so if you start at angle A, you're either going to angle B or you're going to angle D. You're getting to the next closest angle in the parallelogram. Adjacent or consecutive angles are supplementary. They are supplementary. What does supplementary mean? They add to 180. Okay, supplementary angles add to 180. What's the other complementary? Okay, complementary angles, they add to 90. Okay, complementary is 90, supplementary is 180. So if we were to add the measure of angle A to the measure of angle D, we would get 180 degrees. Also, if we were to add the measure of angle A to the measure of angle B, that would be 180 degrees. When you write it like that, you have to put an M in front so that you're talking about the measure of angle A. So it means you're going to plug in a number there. If you just have angle A, that's just representing that angle in the parallelogram. It's not talking about its measure. Similarly, we've got the measure of angle B plus the measure of angle C. We can add B and C, and we can also add C and D. Okay, so adjacent or consecutive angles are supplementary. Again, besides the last one, I think they look pretty obvious in pretty much any picture, but again, sometimes the pictures are not drawn to scale. You cannot always trust the diagram, so you do need to know them just in case they give you one that they say is a parallelogram, but it doesn't actually look like a parallelogram. Okay, now flip it over, because a rectangle is a special case of a parallelogram. Okay, a rectangle is a special case of a parallelogram. So it has all of these properties. Okay, all these things are still true. Opposite sides are congruent. You know that's true about a rectangle. The diagonals bisect each other. Well, that's quite obvious. All angles add up to 360. Opposite angles are congruent. That's pretty obvious because they're all, what, 90. So obviously they're congruent. And adjacent angles are supplementary because they're both 90, okay? But the one additional property that you need to know about a rectangle, or if they say this, you have a parallelogram and the diagonals are congruent, okay? So if the diagonals of a parallelogram are congruent, The parallelogram is a rectangle. Okay, that's obviously not true about the diagram on the front side. If you compare those two diagonals from B to D, it may not be super obvious, but if you look at it hard enough, you can tell that the diagonal from B to D is longer than the diagonal from A to C. But if you've got a rectangle, those diagonals have exactly the same length. So it is a rectangle if the diagonals are congruent. So I see that just being one of those kind of statement questions. It says if the diagonals of a parallelogram are congruent, then the parallelogram is what? And they may say rectangle, rhombus, trapezoid, or I don't know, a square. Well, you'd have to be careful that you don't have square and rectangle as an answer choice, because squares are also rectangles, okay? So squares are rectangles, not all rectangles are squares. Okay, so here's what I